Okay, Algebra 2, welcome back to Unit 4B. We're moving on to a new lesson today, Section 4.8, Operations with Imaginary Numbers. So, back in the day, we learned that you can't take the square root of a negative number. For example, if you plug into your calculator the square root of negative 25 and hit enter, it would tell you that it's undefined. Well, when a calculator does it, a calculator only generates real answers. However, there's these things called imaginary numbers, which are part of complex numbers, that tell you that you can in fact take the square root of a negative number. The answer is just not going to be a real number. So, there's some properties we're going to learn. The first one saying that the square root of a negative number, what you have to do is you pull an I outside of the square root. So let me show you an example. If we know, say we take the square root of 5, we know that we cannot simplify that. It's just the square root of 5, can't be simplified any further. But what happens if we take the square root of negative 5? Well, the negative that's here tells us, the property tells us, that we have to pull an I outside of the radical. So it would become I times the square root of 5. Let me show you another one. If we know that the square root of 36 is 6, without a radical because it's a perfect square, what would the square root of negative 36 be? Now, it's not negative 6. Again, when you have the negative inside the square root, you must pull out an I out of the radical. So it would be I times the square root of 36. And then the square root of 36 is 6. So it would be I times 6. And we wouldn't leave it I times 6. What we would call it is 6I. So just like we don't say x3 and y4, we would say 3x and 4y. You put the coefficients in front of the I. So that's the rule for when we're trying to square root a negative number. We pull an I outside of the radical. And then we try to see if we can simplify the number that's left in the radical. Now, there is another property that won't apply in the beginning of the lesson, but it will come in into the lesson later below. Now, in our answers today, it is okay to have an answer with I in it, but it is not okay to have an answer with I squared. So whenever you see I squared, you must change it to the number negative 1. So again, I in an answer is okay, and I squared turns into negative 1. You'll see more on that below. Okay, so example 1 is some more simplifying square roots. So in A, we have the square root of negative 7. So we have a negative inside the radical, so pull out an I. So it's I times the square root of 7. And then you try to square root the 7, but we cannot do that. There's no perfect square that multiplies evenly into 7. Letter B, pull out an I for the negative. And then can you take the square root of 100? Of course you can. It's 10. So it's I times 10, which we'll call 10I. Letter C, pull out the I because there's a negative inside. Now, the square root of 12, we got to think, is there a perfect square that multiplies evenly into 12? Yes, it is. 4, such as the square root of 4 times the square root of 3 is 12. And then the square root of 4 is 2, so it would be I times 2 times the square root of 3. Technically, this is correct, but the proper way of writing it, if we look back to here when we write it 10I, same thing applies here in letter C. We would call it 2I, then the square root of 3. So whenever you're writing things in order, it would be the coefficient like 2, then the letter I, and actually the radical would come at the end if there's a radical in your answer. Letter D, the square root of negative 80. I pull out an I. And then I think, is there a perfect square that multiplies evenly into 80? Yes, there is. That would be 16, because 80 divided by 16 is 5, so square root of 16 times the square root of 5. Then the square root of 16 is 4. And then we put it in order, just like letter C, 4i, and then the radical last. So 4i times the square root of 5. Okay, I want you to pause this now and try letter A, see what you get. Now for letter A, you should have pulled out an I out of the square root of 30. And believe it or not, there is no perfect square that multiplies into 30, so that's your answer. Letter B, pause it now and try this on your own. So you should have pulled out an I. What perfect square multiplies evenly into 75? It should be 25. And 25 goes into 75 3 times. So then the square root of 25 is 5. And then we rearrange it in the proper order, 5i times the square root of 3. Okay, in example 2 on page 34, we're going to transition into adding and subtracting complex numbers. So the directions say add or subtract to simplify the expression. I know I'm going to add or subtract here in letter A, because if you look at the in between the parentheses, you have a plus sign. Now this is a very easy section. All you're really doing here is combining like terms. So you would do 4 plus negative 4, which would be 0. And then you do the other like terms together, negative 3i plus 3i, which would be 0i. And then you would simplify from there. So 0 plus 0i, well, you can drop the 0. And then 0 times I would just be 0. It's just like saying 0x is 0. Not really the best example to start off with when we're learning how to add and subtract. But remember, sometimes things can't kind of cancel out when you're adding and subtracting. Letter B is a subtraction problem. Look at the minus in between the parentheses. So we are going to subtract like terms. So we do 5. Let me show that a little different. 5 minus negative 2. That would be 5 plus 2 is 7. Then add or subtract the y's, or the i's, subtract the i's. Negative 3 minus 4i. Negative 3 minus 4i. Sorry, I meant to say negative 3i minus 4i, which would be negative 7i. And then we stop there. That's our answer. We cannot subtract those. They are not like terms. So we stop there. This thing together, this 7 minus 7i, that's our answer. That's called a complex number. And all complex numbers are written in the form a plus or minus bi, as you can see that I wrote this answer here. Okay, let's show you guys another one. So we are subtracting because we have a subtraction in between the minus sign. So we're gonna, a subtraction in between the parentheses. My kid's distracting me over here. So 1 minus 3 would be negative 2. And then the i's, we got negative 5i minus negative 2i, which would change to plus 2i. And then negative 5 plus 2i would be negative 3i. So then we say our answer is negative 2 minus 3i. Okay, so that right there in those three examples, you just learned how to add and subtract complex numbers. We only had 3 examples here, so feel free, if you want to see more examples, go into YouTube and type in add and subtract complex numbers. Add and subtract complex numbers. Okay, next up, in the next part, we're going to learn how to multiply complex numbers. So this is where our, earlier we learned that property I squared turns into negative 1. That's going to finally come into play here. So here, think of this as x's for when you begin it. You know, we would distribute here, right? You know, 3i times negative 5 would be negative 15i. And then you would multiply again. 3i times 2i would be plus 6i squared. So after that, yeah, it looks like it's done, but it's not. So the properties earlier in this lesson says you are not allowed to have I squared in an answer. You must change I squared to become negative 1. So what this does is it becomes 6 times negative 1, which is minus 6. And then bring this down. And then it's just about done. Technically, you want it in the right order. Remember, it's in the order a plus bi. So this should be written negative 6 minus 15i. Okay, let's try another one, letter B. We have a binomial times a binomial, so we are going to have to FOIL here. So first, outsides, insides, and last. So I multiplied my 4 times. Now I'm going to see about combining like terms. Negative 4, nothing can really happen with the negative 4, so let's just bring that down. The 2 next terms, these guys are like terms. We can combine them to make minus 11i. And then this guy, remember, I squared is not allowed, so this becomes minus 6 times negative 1, which is plus 6. So we still have 3 terms. We now actually have more like terms. If we look, let's do black. These 2 can add together now. Negative 4 plus 6 would be 2. And then bring down your minus 11i. Okay, so we FOILed, we multiplied our 4 times, and then we combined like terms, also considering the I squared, remember, is negative 1. Okay, let me show you another one here. Again, we're going to FOIL. So first, outside, inside, and last. So negative 3i times 5 is negative 15, and then I times I would be I squared. Okay, we can clean up a little bit here. These guys can combine to have 10i minus 12i is minus 2i. Bring that down. Let's worry about that minus 15i squared. So we have this, that turns into negative 1. So this would be minus 15 times negative 1 would be plus 15. And then from there, we can combine like terms again. 8 plus 15 is 23. And then bring down your minus 2i. Okay, so that section in example 3 was multiplying complex numbers. We distributed in A, and then we FOILed in B and the U-do. If you need more examples, please make sure to check into YouTube and type in multiply complex numbers. So multiply complex numbers into YouTube. Okay, so right here, so we learned all of these things today, especially the square root of a negative is I. So let's apply that to some actual problems now. So example 4, solve by square roots. So we're going to learn, we're going to see what it is to solve equations and get imaginary answers. So we learned last week that solving by square roots is when you have an x squared in a problem, but not the other regular linear x. So to solve this, remember the first step was get x squared by itself. So first we want to subtract 20. And then, again, I'm still working on dividing both sides, getting x squared by itself, divide both sides by 5. Now that x squared is by itself, remember we can get rid of the x squared by taking the square root of both sides. Remember, a square root cancels a exponent of 2. So that leaves you with, on the left, x by itself. And then on the right, remember you have to have a plus minus. Remember that the plus minus means, let me clean that up. Remember that nope, that's not what I wanted. Remember that the plus minus means you're going to have two answers. Now, the square root of negative 4, remember that the square root of 4 is 2. So the square root of negative 4 would be, don't say negative 2, you would say 2i. So again, if the square root of 4 is 2, the square root of negative 4 is 2i. So we have two answers here, 2i and negative 2i. Okay, let's try another one, very similar to A. We are going to solve by square roots because we have an x squared and we don't have the linear x term. So I'm going to work on getting x squared by itself. First, I'm going to subtract 32 to get equals negative 32, very similar to A. Next, divide by 2. Remember, guys, I'm working on getting x squared by itself. So I now have x squared by itself. I want to get rid of the square roots. Or get rid of the exponent of 2 by square rooting. So x equals, don't forget to put your plus minus. And then I want you guys to think about what's the square root of negative 16. So think about the normal square root of 16. You know that the square root of 16 is 4. So what's the square root of negative 16? 4i. Okay, let's show you a couple more. Solve by square roots. So here your first step would be subtract 81. And then you would, now that x squared is by itself, we're going to square root both sides to get rid of the exponent. throw in your plus minus. The square root of 81, you know, is 9. So the square root of negative 81 is 9i. Letter B. All right, got a couple steps here to get x squared by itself. First, we want to add 10 to both sides. Then we need to divide both sides by 7. So now we have x squared by itself. Let's get rid of the exponent by square rooting both sides. So we have x by itself equals, don't forget your plus minus. Did I do that last problem? Yes, I did. Sometimes I gotta double check my work. Now the square root of 20, let's pull that guy aside. The square root of 20, by the way, I'm calling it the square root of 20. That we know an I is going to come out because of the negative, but I just try to think of it in a positive note before I worry about the I. So the square root of 20 with a perfect square could be broken up as 4 times 5. The square root of 4 is 2, so it would be 2 times the square root of 5. And then the I is just going to go in between the 2 and the root of 5. So 2i times the square root of 5. Okay, there's only a few problems left. You pretty much got the gist of it. I'll show you one more, though. Just kind of looking at my time there at the 22-minute mark. I try not to go higher. I'll show you one that's really kind of all you need. It's just quadratic formula. You guys learned it already the other day, but I'm just going to show you what happens when we have in I in our answers. So A is 2, B is negative 3, C is 5. Remember that the formula is, you guys should have it memorized actually. I did mention that the other day. Always memorize your formulas. I don't give many, so memorize them. So we plug them in now. So negative b is a negative, so that's double negatives, would be a positive 3. And then b squared minus 4 times a times c divided by 2 times a. After plugging in, I showed you that the next step is multiplying your 3 times here, here, and here. So negative 3 squared is, it's too long of a square root. Negative 3 squared is 9. And then negative 4 times 2 is negative 8 times 5 is negative 40. On the bottom, 2 times 2 is 4. Then we are going to subtract in the radical. Remember, we always want this radical down to one number, so 9 minus 40 is negative 31. And then we just clean it up a little bit. We try to simplify the radical. Notice that inside the radical is a negative number. So we must pull an I outside the radical. So how we would write it is 3 plus minus I times the square root of 31 over 4. And can this fraction be reduced? Absolutely not. 3 cannot divide with 4. Therefore, you cannot reduce this fraction. And that ugly thing is your answer. So that's it for the lesson. I'm at the 24-minute mark. The next two examples you really don't need. If you want to work them out on yourself, go for it. But it's just more repetition. It's kind of redundant. All right, lessons